everyone, welcome back. My name is Catherine and I am an OpenSciEd teacher, facilitator, and writer. And today I'm going to walk us through lesson 2 of the P.1 electricity unit. I love this lesson because we get to right off the bat start tinkering hands-on with some materials and really diving in, trying to figure out what is actually causing or allowing for electrical energy to transfer in our electrical grid. So let's take a look at how we get here to the start of lesson 2. Back in lesson 1, while we were investigating this energy crisis in Texas that happened in February of 2021, we really realized through our consensus model that while there's a lot that we don't understand around the power grid system, that we do agree that there are several subsystems that need to work together in order for electrical energy to transfer. And we were really wondering in particular a lot about this transport part of our model. We had a lot of questions about this because we don't really understand what is here or how these connections are set up or how they need to be or why they have to be a certain way. But they know they need to be there so that we can get energy from the source to our community. So in this lesson, we're trying to figure out what are these structures and how might they allow for electrical energy to transfer. So let's take a look at lesson 2 here at a glance. This is an investigation routine lesson. It does have a hands-on investigation component. And this hands-on investigation does require some significant prep time on your part. The teacher guide says about 90 minutes. That is to set up the power strips and all of the materials that we're going to use in this lesson. The good news with this is that it's a one-time cost with the setup. So once you have your materials ready and prepped for this investigation, you can reuse them from year to year. Lesson 2 here is 2 class periods or 2 days long. And remember, in OpenSciEd, when we say 1 day, we mean 1 45-minute class period. So throughout these 2 class periods, these 2 days here in lesson 2, there are 3 key opportunities for students to sense make around this idea of what are the electrical structures and how are they connected to each other to allow electrical energy to transfer in a system. So this very first key sense-making opportunity occurs in day 1, where students are using a dissected power strip to create a circuit and explain how this power strip is actually able to allow for electrical energy to transfer. And we figure out here that there has to be some metal-to-metal connections to allow for this to occur. And at the beginning of day 1 here, we navigate into this investigation by relying on those photos from the home learning that occurred at the end of day 1. And we realized that in those photos and even in the room around us, a lot of the electrical grid system is hidden within boxes or it's hidden within the walls. And so we need a way to make those visible. And so we were using a power strip here as an analogy for what those structures that we can't see, what they might look like. Moving into day 2, we start off with our second sense-making opportunity where we develop a class consensus model for the power strip system. And this is to allow for some clarity if students from the previous day were unsure of these connections. And as a class, we named this system a circuit. From here, we think about, okay, if our circuits were to represent parts of the building that we could not see, then can we just combine our circuits together and actually model an entire power grid system? So our third and final sense-making loop and opportunity for students come when we take our power strips, we take our class set, and we connect them all together and model a city. So we have one power source, a battery, to power our electrical strip system. And we use our electrical city here to model what breaking or shorting this larger circuit could look like and talk about how this connects to the blackouts that we looked at the previous lesson. So through these investigations, we figure out that energy will transfer when we have a complete circuit and will not transfer if there's a break in any of those circuit paths. We also figure out that we can create a short circuit where most of the energy does not go where it's intended and rather is stuck in a loop. And in either of these situations, we have a relatively small change to the system, but that small change could cause blackouts at a small or large scale across buildings or neighborhoods. So let's dive into these key moments a little bit further and make sure we feel prepared to teach this lesson in our classrooms. So the first opportunity comes again in day 1 in part 3, where we're dissecting a power strip. This is identified as investigation A, and students just need here the power strip and a Phillips screwdriver. They use the screwdriver to open up the back plastic and reveal the structures inside. And just to note here, some of your power strips might have a singular triangle screw. If that's the case, you can either use a special triangle screwdriver to remove it, or you can simply remove all of the other screws with the Phillips screwdriver and then just pop the case off and that last screw. You do want to emphasize with students to keep track of their screws because you will need them to reassemble these systems and use later in the day or use in future years. Once students get their structure open and they see what's inside, they have a handout where they're writing down key structures or parts that they think are needed to help explain how this power strip works. From here, we've identified structures that we think are important. So now let's see if we can use them to actually light up a light bulb. This is referred to as investigation B in the materials. And here you give students a power source in the form of a battery. You give them electrical devices in the form of these incandescent grain of wheat light bulbs. And then you give them some alligator clip wires so that they can use those alligator clip wires to connect the battery to the power strip and then connect the light bulb to the metal strips in the power strip. And once students connect one device, you try to see, well, can I get more than one device lit, or can I make the switch work? From here, students are going to develop a model to try to explain how these structures work. And this is in the second half of the handout that they're using through this investigation. And it is okay here if students are unsure how to create this model or why their connections were a certain way, or even if they were unsuccessful in powering the strip at all of this is okay. They're going to just put their current thinking down on their sheet, as clarification will come in the next day of this lesson. So that clarification comes when we, in the beginning of day 2, in part 8 here, create a power strip consensus model. And we do that by prepping ahead of time one poster to use for all classes that'll look like this. And there's a lot of directions in the teacher guide on how to do that. But through this conversation, what you're looking to clarify with students is that there are metal strips and wires that have to be connected in a particular way. Those strips are connected to the color wires that come out of the cord. We want to emphasize the switch connections that exist within the switch itself. And there's a GIF in the slides to help students see this, as we don't want them dissecting the switch part of their power strip. And you can model this with a movable component of your poster. And then we also want to emphasize that the energy source to power strip connections, as well as our devices to power strip connections, have to create 2 separate complete paths, both to and from the battery. And again, we name this here as a circuit. So in the next component of our lesson, we say, okay, if we have all of these circuits to be individual buildings, then can we take our individual circuits and make a grid? And so we do this in what is labeled as investigation C, where we connect all of our power strip systems together into one grid with a substation that you will have set up in your room ahead of time. And there's a fun little optional activity where students can name their building and decorate their building if you have the time and the desire to do that. And then lastly, once we have our system created, Investigation D has us use our electric city to model what broken and short circuits look like and how they result in different blackouts at different scales. So we'll break one of the lines to represent a broken circuit, and we'll lay some sort of metal object like scissors or a paper clip across, or even your keys, across two of our metal connections to develop a short circuit. And so from here, we're wondering if these short or broken circuits could actually cause what we saw happen in Texas. And so that's what we'll investigate in the next lesson, lesson 3. So lastly, I just want to quickly go over some tips and tricks for you to help you be successful here with lesson number 2. First off, it's super important to make sure that the plug is removed from any power strips that get dissected. You do not want them to be plugged into the wall. It would be unsafe once they have been opened to actually use them as intended. This is an optional material, but if you have battery holders, these could be a really helpful way for students to connect to the battery. So they can just like clip in the battery into the holder and use the alligator clips so they don't have to tape any alligator clips to the battery. So if you have that available, use them, but it's not required. Additionally, for your electric city, you want to keep this set up and you want to test this ahead of time. And it can matter where you are shorting your circuit. So you want to test that out again ahead of time. If you want to see the whole city or a whole neighborhood go out, then you want to make that short closer to the actual battery. Practice doing that before you do this together with your students. And then you want to keep this set up. Not only have it set up ahead of time, but keep it set up afterwards because it is used again in future lessons. If you don't have the physical space to do this, then perhaps set it up on a prep room cart that you can wheel in and out of your classroom. Lastly, for our glossary, we do have some terms that we co-construct together. We do this within the discussion on our consensus power strip model at the beginning of day 2. And there are some other words that we encounter. There's a home learning reading where we see these, but we aren't adding them to our glossary yet because we haven't had the opportunity to fully sense make around what they mean. And so even though we're using short and broken circuit, for example, when we create our electric city, we are not adding them yet to our glossary, as we'll make better meaning of those terms in the next lesson. As far as posters, you want to make sure that you have your initial class consensus models from lesson 1 handy. The power strip model that you will use in this lesson is not really used again, so that is something that you can put up and then take down but not leave up. Students will see their progress tracker for the first time in this lesson. Add that to their binders. And then again, your electric city, you want to have that available to bring out again in a future lesson. Thank you for joining me today to hear about lesson 2. I hope you find this lesson as exciting and fun for students as I do. And I hope you join us again in a future video as we move through lesson 3.